Cloud. Okay, we're recording. Everybody's muted out. I appreciate you guys coming by this morning. I know everybody's busy, especially in our other locations up in the northern part of the state, St. George, Idaho Falls. If anybody is joining us, Kip is in Salt Lake City. It's cold up there, and I know you guys are probably running heat-related or cold-related calls this week. So we'll get the training done. I've got a bunch of stuff sitting here on my desk that hopefully will make it easier about heat pumps. And if you have any questions, you can reach out to me through email at mmayberry, MMAYBERRY at customcooling.com, CUSTOMCOOLING.com, where you can get a hold of your branch managers and we can hook you guys up to me in case you got any questions. Today is course 6 of HVAC and heat pumps. Oh, there we go. After this course, students should be able to describe the operation of the reverse cycle refrigeration or heat pumps, explain the function and operation. Let me see if we can get the screen a little bigger. There we go. Explain the function and operation of the heat pump system and components. List heat sources commonly used in heat pump systems. Discuss how a heat pump efficiency is determined. Explain the concepts of coefficient of performance and auxiliary heat, which some of you may have to actually do some training with me on it. It's been a while since I've done that. Describe the control sequence of an air-to-air heat pump system, which is very common here in Phoenix. Explain how heat pump efficiency can be increased, and discuss preventative maintenance on a heat pump system. An air conditioning equipment can only pump heat in one direction. Heat pumps can pump heat 2 ways. Heat pumps have a 4-way reversing valve. 4-way reversing valves control the direction of flow of the heat-laden vapor between the low and high pressure side of the system. Here's a diagram of a heating system. The heat pump heating, it functions as the evaporator, and the condensing unit actually functions as the evaporator in the heating mode, and the evaporator, the blowish section, functions as a condenser in the heating mode. In the cooling, the condensing unit obviously functions as a condenser, and the indoor section functions as the evaporator in the cooling mode. Air conditioners pump heat from a low temperature inside the structure to a higher temperature outside the structure. There is heat in a substance that is cooled to minus 460 degrees. At 0 degree outside air temperature, there is still 85% usable heat in the air. Heat pumps have the ability to absorb heat from the structure in the summertime and discharge it to the outside. And heat pumps are able to absorb heat from the outside air and discharge it into the inside of a structure. 4-way valve allows the heat pump to pump heat in 2 directions. It diverts the discharge gas to either the heating or cooling of the conditioned space. Refrigerant is directed from the compressor to the indoor coil in the heating mode, and refrigerant is directed from the compressor to the outdoor unit in the cooling mode. Controlled by space temperature, it's a pilot operated valve, 4 piping connections on the valve. You can see in this direction here, there's direct heat, direct acting reversing valve is controlled by a solenoid coil. Here's your hot gas from the compressor going through. Here's, looks like this is connected to the outdoor coil, and here it is here. That's a movable slide. I actually, if you guys, I'll do my best. If it doesn't come through, I won't do it again. But here's a reversing valve. You've seen them before, correct? But we actually cut away a reversing valve here, and you can see this reversing valve on the inside. Here is the slide portion of it. This piece actually slides. You can see it here, how it slides. And that refrigerant goes through here, just like in this diagram. Hot vapor comes down through this side, and this is probably going to be your suction side, and it slides. So if you guys look right here, this is actually a neoprene washer. It's flexible plastic. So this is why it is so important when you're talking to your young techs about keeping this in hot block, like the solder weld hot block back here, or wet rag, or actually covering this in a wet rag to protect this neoprene washer that's right here. Because when you burn this valve, it actually will still slide on the inside, but it will no longer work because you melted this seal. So I don't know if you guys can see that. So that's what the inside of a reversing valve looks like. In cooling, pilot operated reversing valve is controlled by the system pressure. There's, you see right here, there's a system high pressure pushes the slide to the right. Here you have connected to the outdoor coil. Here's your suction to the compressor. This is connected to the indoor coil. This is in the cooling mode, just like what we saw here a second ago. In heating, here's your hot gas from your compressor. Goes down here to the indoor coil, so this hot gas is going to the indoor coil for heating. Connected to the outdoor coil, returning this back to the compressor. You can see all the changes here. This is in the heating mode. You can see this here, there's your slides. This is pushing. Here's actually a little bit better diagram. This is a steel reversing valve coming out of a Train package unit from the early 90s. This is solid steel that was taken out. You can really see these tubes that are used for controlling the slides on this one. It's really defined. This is a beautiful reversing valve. You know, they're no longer made in this heavy duty steel. Most are in a brass body, but you can really see it. Types of heat pumps. Air is not the only source from which a heat pump can absorb heat, but is the most popular. Other heat sources for heat include water and earth. A typical water to air heat pump uses 3 gallons of water per minute in the heating cycle and 1.5 gallons of water per minute in the cooling cycle per ton of refrigerant, or per ton of refrigeration. Solar assembled heat pumps. These pumps capture heat from the sun. The heat is then brought to usable levels for heating homes. Some systems are specially designed to operate in conjunction with solar heat. Air-to-air heat pumps are the most popular. It's a basic sealed system component of a heat pump, are the same as an air conditioner, but the terminology changes. In a heat pump, the terms indoor coil and outdoor coil are used. The function of each coil changes as the operating mode of the heat pump changes. Functions of coils in the cooling mode. An indoor coil absorbs heat by boiling refrigerant at low temperature pressure in the evaporator. An outdoor coil rejects heat by condensing a high temperature and pressure vapor to a high temperature and pressure. Did I read that right? But condensing a high pressure to a high temperature pressure in the condenser. Refrigerant from the compressor is first pumped to the outdoor coil. Here we are again. Hot gas from the compressor. It's going to the outdoor coil. We're back to this, the same drawing. Here we are in a system. The compressor. We're looking at right here, looks like this is a cooling mode going through the system, through the condenser, through the condenser, and then back through to the evaporator in cooling mode. Functions of coils in the heating mode. An outdoor coil absorbs heat by boiling refrigerant at a low temperature and pressure. An indoor coil rejects the heat by condensing a high temperature and pressure vapor to a high temperature and pressure vapor at the condenser. Hot gas from the compressor is first pumped to the indoor coil. Here's that picture. Here it is in the heating mode. You can see it coming out and going to the evaporator, which is now your indoor coil. Your indoor coil, you got that heat, is that correct? That's the outdoor coil, sorry, outdoor coil. You're taking that heat into the indoor coil. Air to air heat pump, not hair. I'm always thinking hair, sorry. Mode of operation is determined by which way the hot gas from the compressor is flowing. Mode of operation can be determined by touching the gas line to the indoor coil. In the cooling mode, the gas line will feel cool. In the heating mode, the gas line will feel hot. Refrigerant line identification. The larger diameter line is called the gas line because only refrigerant vapor flows through it. The gas line is a cold gas line in the summer and a hot gas line in the winter. The smaller diameter is called the liquid line because only liquid refrigerant travels through it. During the cooling mode, the liquid travels to the indoor coil, and during the heating mode, the liquid travels to the outdoor coil. Operating in a heating mode, you can look at this. High temperature liquid metering device to the evaporator. We saw that in the original, a little bit different picture. In a cooling mode, again, you can see the refrigeration cycle. Metering device is especially designed for heat pump applications. There must be a metering device at the outdoor unit in the heating mode, and there must be a metering device at the indoor coil in the cooling mode. Thermostat expansion valves maintains desired superheat in the evaporator. Check valves are piped in parallel to the TXV to allow refrigerant to bypass the control when needed. In a heating mode, the refrigerant flows to the TXV at the outdoor coil, and the refrigerant bypasses the TXV at the indoor coil. In the cooling mode, the refrigerant flows to the TXV at the indoor coil, and the refrigerant bypasses the TXV at the outdoor coil. Here at Custom Cooling, a lot of companies that I've worked at, when we replace compressors, a lot of times we'll replace the check valves because they're really hard to determine. System is already open. Most times we'll replace the check valves, and it just makes it easier. And then that way you know the check valves are brand new and they're in good shape. Systems of TXVs. You can see right here in a cooling mode, hot gas, outdoor coil, here's your TXV, here's your checks. Same thing, here's another check. Back through, your bulb placement, back to your reversing valve. Systems of TXVs, again, here's your check valves. This is a basic diagram, but this is still pretty close. Here's your check valves. Cap tube is commonly used on heat pumps. Will allow refrigerant to flow in both directions. Sometimes two cap tubes are used with the check valves. There must be a dryer strainer at the inlet of the cap tube to ensure that the tube does not get clogged. Here I have a cutaway. If you guys want to see what a liquid dryer looks like, we cut a dryer in half. Here's what the actual desiccant looks like on the inside. This block wall. It's going to be just like you guys out there doing market work or refrigeration work where you're using like an RC4864 dryer shell. It's the same style. And here you can see inside, that is the brass screen on the outlet. Usually on a bidirectional liquid line, there'll be 2 brass screens on both in and out. But that's what its dryer shell looks like. Ball type check valve. Pressure refrigerant pushes the ball down, closing the valve. A ball is pushed on this one. Ball is pushed up the pressure refrigerant. Refrigerant can now pass through the check valve. Combinations of metering devices uses a capillary tube at the indoor coil, used in the cooling mode. Load is relatively constant in the warmer months. When you use a thermostatic expansion valve at the outdoor coil, is used in a heating mode, allows system to reach maximum efficiency quickly. Electronic expansion valves can meter refrigerant in both directions. If the indoor or outdoor coils are closed together, one device can be used. The correct superheat will be maintained in both heating and cooling. I have not seen an electronic expansion valve before on a heat pump. It must be on the bigger ones. I showed you guys an EEV in an earlier class that my son sent me on a 200-ton Daikin, but you guys doing supermarket work are seeing stepper valves on your cases and whatnot. So you probably see more of them than we do on the air conditioning side. Orifice metering devices you use in conjunction with a check valve. One device is at each coil. The bore at the indoor coil is larger than the bore at the outdoor coil. Normally used with a bi-flow filter dryer, which we just talked about. With liquid line accessories, 2 standard filter dryers can be used on system with check valves. Only one dryer will be in the refrigeration circuit at a time. They installed with arrows pointing in the same direction as the check valves. Make sure you look at the arrows. Bi-flow filter dryers, there's 2 dryers in one, designed for heat pump applications. Here's your cooling mode, refrigerant to the indoor. Here's your check valve. Looks like through here. Refrigerant from the outdoor coil. In a heating mode, the check valve is closed. Refrigerant from the indoor coil passes through and goes to the outdoor coil. Air-to-air heat pump application, usually installed in milder climates, temperatures as low as 10 degrees. In the winter, the outdoor coil absorbs the heat. The difference between the outdoor and evaporator temperature is about 25 degrees. It's kind of a rule of thumb. If outside air temperature is 10 degrees, the refrigerant will boil off at approximately -15. The compressor and the system lose efficiency as the evaporator temperature goes down. So you guys know, on a heat pump, your outdoor unit is outside, maybe up on a roof. As it gets colder, it no longer begins to heat the home. That's why you hear a lot of times heat pumps in really cold climates, they're not as efficient. The system loses capacity as the outdoor air temperature drops. Sometimes we'll combat that with some fan cycling. Auxiliary heat required when a heat pump cannot provide all the heat a structure needs. The heat pump is a primary heat source. Auxiliary heat could be electric, oil, or gas. Electric heat is the most common type or strip heater. As the temperature outside drops, the structure requires more heat and will bring on the strip heater for auxiliary heat. Balance point occurs when the heat pump can pump in exactly as much heat as the structure is leaking out. Above the balance point, the heat pump will cycle on and off. Below the balance point, the heat pump will run continuously, and second stage, auxiliary heat will be energized. Coefficient of performance. 1 watt of usable heat is supplied for each watt of energy used. Usually it's using electric resistant heat. This is called 100% efficient. The coefficient of performance is 1:1. The output is the same as the input. On an air-to-air heat pump can have a COP of 3.5:1. meaning when 1 watt of electrical energy is used by the compressor, it can furnish 3.5 watts of usable heat. Well, if you asked me to explain that again, I'd probably get lost. I haven't seen that much in a long time, so we don't look at it too much. Coefficient of performance, a high COP occurs during higher outdoor winter temperatures. A heat pump COP falls as the outdoor air temperature falls. A typical air-to-air heat pump has a COP of 1.5 to 1 at 0 degrees. Some manufacturers controls to shut off the compressor at temperatures of 0 to 10 degrees. Water to air heat pumps might not need auxiliary heat since the heat source for water is constant. Water to air heat pumps have a COP as high as 4 to 1. Here in Arizona, we have a lot of heat pumps that have, for our big lot stores, we'll have outside air thermostats, and we shut them off. They don't want them on at all, and they'll actually shut them off. Split system air to heat pumps. Air to air systems can be split or package type. Both heat pumps and straight cooling units look the same. Split systems require the installation of a gas or liquid lines to connect the indoor and outdoor units. Here's a system overview. Functions as the evaporator in the heating mode. Most of you guys have seen this already. Field installed refrigerant lines. Functions as a condenser in the heating mode. There's your indoor coil. Indoor units, part of the system that circulates the air within the structure. It contains the fan and the coil and often an electric strip heater. The refrigerant coil must be located in the airstream before the auxiliary heating coil, and the indoor unit may be gas or oil fired. If gas or oil furnace is the indoor unit, the coil must be located in the outlet airstream of the furnace. I've never seen an oil furnace, so I'm not sure what they look like. If a gas or oil furnace is used, the heat pump will not operate when they're operating. Heat pumps added to electric furnaces should have the coil placed after the heat strips. I'm from California. Electric strip heats are like a huge no-no. I've only seen maybe 1 or 2 in my life in the trade. Just like I said, in California, electric strip heat is almost illegal. Air temperature of the conditioned air. Air temperatures of a heat pump are not as hot with fossil fuel equipment. Maximum heat air supply temperatures are around 100 degrees. Most heat pumps require a minimum of 400 CFM per ton of refrigeration. Supply air temperatures will fall when outside air temperatures drop, which again, we've talked about that 0 to 10 degrees. A lot of times we'll just shut them off. System overview. There's your return air from the conditioned space. This looks like supply registers, heated air at 100 degrees, air handler or the condenser in the winter. Outdoor unit installation, much like a regular air conditioning installation, they must have good air circulation around it. Prevailing winds will affect the performance. In the wintertime, the outdoor coil will collect moisture and will freeze on the coil. An outdoor coil should be installed so that it's raised above the ground to allow defrost water to run to the ground. A defrost system is provided to defrost ice from the outdoor coil. You guys have seen pictures with the condensing unit is encased in ice. That's usually an indication that your defrost circuit is not working. Package to air heat pumps has all the sealed system and electrical components in one housing. Works much the same way as a packaged air conditioning unit. Only one power supply is required. Supply and return duct must be field installed. Exterior view. I've actually only seen this a few times. California, Arizona. Really, probably, I don't know, the Utah guys see this a lot. I'm looking at the St. George group. When I lived in St. George, I didn't see too much of them. No?
Too much of what? Shoddy.
Like a package unit on the side of the house and the ductwork going in the side?
Yeah, no, package units are typically on the roof here.
Okay. So where you see a lot of these will be where you have a basement. A lot of them are houses with basements, and they'll go down underground, and they have like the vents are down on the floors. Most of the questions can go to your service manager. Well, something that they didn't cover that is really kind of popular. Here's an accumulator. We see the accumulators and heat pumps. They didn't really talk about it, but I cut one in half. Here's the dip tube. You can kind of see the inside of an accumulator on an air conditioning unit. And this dip tube actually goes down on the inside. There's a little screen at the bottom of the dip tube for bringing oil back. You guys can see that, for bringing oil back. And this is down on the inside. It actually clips into place and makes sure that during the refrigeration cycle, when it goes back and forth between heating and cooling or defrost, that there's no liquid coming back. And this is actually a suction accumulator that we took out of a heat pump. If I ever come to your branches, I'll bring this stuff to you. It's you guys can play with it and take a look at it. So this is the basic class for heat pumps. Most of you guys are working on heat pumps already. This presentation is on the cloud if you want to review it again. For anybody that missed it, if you have any questions, I'll try my best to answer them. Otherwise, your service managers can definitely help you out. Looks like we're done in 30 minutes. You guys work safe, be good humans, and we'll see you for the next training session.
Good job, Mike.
All right, Sean. Thanks, bud.
Thanks, Mike.
All right.
Thanks, Mike.
See you later, Mike.
Bye-bye.
Thank you.
Leave the meeting, but the screen keeps going small.